It works on my machine. That's probably the most famous sentence in software. And containers killed it. Today I'll show you how Docker actually does that, and why it became close to mandatory for professional teams. Before this is over, you'll see exactly what a container shares with your computer and what it doesn't. The 2 Linux features underneath Docker that make the whole illusion work, and the one moment in production where it works on my machine quietly becomes true everywhere else too. Before containers, if you needed to run 3 applications on the same server, all 3 had to share everything. The same operating system, the same libraries, the same directories. And that's exactly where the problem lived. Say one Python app needs version 2.7, another needs 3.11. Both want to use port 8080. On top of that, the local environment never quite matched the server. You develop on a Mac with the newest version of everything, but the server runs older builds, and what works in one environment breaks in the other. The old fix was virtual machines. But every VM carries an entire operating system, its own kernel, its own drivers, its own package manager. To run 3 applications, you need 3 complete operating systems, running at the same time. All of that is heavy, slow to start, and wastes memory and CPU. So what if there were a way to isolate each application without a full operating system for each one? That's exactly what Docker does. Docker is a containerization platform. It packages your application together with everything it needs to run, and isolates it in its own environment. Unlike a VM, a container doesn't carry its own operating system, it shares the host's kernel. Think of it this way, a VM is like renting an entire house. You get the kitchen, the bathroom, the garage, but you pay a lot, and it takes a long time to build. A container is like renting a room in a hotel. You get your own private space, but you share the building structure with everyone else, which makes it cheaper, faster, and lets a lot more people fit. So how does Docker create that isolation without a separate operating system? It uses 2 features of the Linux kernel, namespaces and cgroups. Namespaces create a kind of illusion. Each container believes it's the only thing running on the system. It has its own processes, its own network, its own file system. The process inside the container thinks it's PID 1, but on the host it's just one more ordinary process. Groups control how much of each resource a container can use: CPU, memory, disk, network. That's what stops one heavy container from eating everything and taking the others down with it. Picture an apartment building where every unit has its own circuit breaker. If a neighbor runs everything at once, they trip their own breaker, not yours. But how do you define what goes inside each container? That's the Dockerfile, a recipe describing how to assemble your application's environment. Look at the first line, from node 20 Alpine. That sets the base image. It's like saying start with node 20 already installed, on a lightweight version of Linux. Workdir/app sets the working directory. Copy package .json copies the dependency manifest. Run npm install installs them. Then you copy the actual code and define the command that starts the app. Each instruction creates a layer, and those layers get cached, so if you only change your code, Docker won't reinstall your dependencies. It reuses the cache from the layers before it. In practice, that's why the second build is so much faster than the first. Then you build with Docker build, which produces an image, an immutable, portable blueprint. You run it with Docker run, and that creates a container from that image, the live, running instance. It's the same difference as a class and an object in object-oriented programming. The image is the class, the container is the instantiated object. But what happens when your app needs more than one service? In practice, an application rarely runs alone. There's the backend, the database, the cache, the queue. Docker Compose lets you define all of those services in a single file. Picture a Compose file with 3 services defined: the API, Postgres, and Redis. The API section points to the Dockerfile, lists its ports, and declares that it depends on the database being ready. Postgres uses an official image straight from Docker Hub, defines environment variables, and a volume to persist data. Redis is even simpler, just the image and the port. Run Docker Compose up, and everything comes online. The network between them is created automatically, and the API can reach Postgres by name, no manual IP configuration required. That solves a real onboarding problem. Any new developer on the team runs one command and has the entire environment running, with nothing to install, no version to configure, and nothing conflicting. But what happens when this needs to run in production, at scale? In production, the flow shifts a little. You don't run Docker build by hand, your CI does it for you. A developer pushes code, the pipeline runs the tests, builds the image, and pushes it to a registry. A registry is like a Git repository, but for Docker images. Docker Hub is the most popular one, but larger companies often use private registries, like AWS Elastic Container Registry. Every version gets tagged, so you can roll back to any previous version in seconds, instantly. And because the image is immutable, what runs in production is exactly what ran in tests. There's no more works on my machine, because the machine is the same one, the image is identical everywhere. Docker does have limits though, and when demand grows enough, it's not the whole story anymore. Let's actually weigh the advantages first, because they're real and worth naming precisely. The first advantage is portability. The exact same image runs on a Mac, on Linux, on AWS, on Google Cloud, anywhere Docker is installed. Then there's isolation. Each container has its own space, so a broken container doesn't take down the others, and you can run different versions of the same language side by side with zero conflict. Third is speed. Containers start in milliseconds, which makes the whole development loop faster. Change something, rebuild, test, seconds later. Last is consistency. The Dockerfile is the documentation of the environment. You don't need a wiki page explaining how to install every dependency. The file describes all of it, declaratively. But not everything works this cleanly. The first real challenge is security. Because containers share the host's kernel, if one manages to escape its isolation, it gets access to the entire system. Running a container as root is a genuinely large risk. The second is data persistence. A container is temporary by design. When it dies, whatever's inside dies with it, so you need volumes to persist anything that matters, and that adds its own complexity. There's also operational complexity itself. For a genuinely simple app, Docker can be overkill. Dockerfile, compose, registry, orchestration, all for something a single small team with one simple API might not need. And last, network debugging. Tracing a networking problem between containers means actually understanding how Docker builds its virtual networks. And when something breaks, you can't just open the container and poke around the way you would on a normal server. So when is it actually worth it? It's worth it when your team has more than 2 or 3 people, each on a different operating system. Docker guarantees everyone runs the exact same environment. Use it when your app has multiple services, database, cache, queue, backend. That's a single command instead of a checklist. Another case is when you have CI/CD and need reproducible builds. The image itself becomes the artifact that gets promoted, unchanged, from test to production. But if it's a personal project with one simple API on one server, Docker can be unnecessary complexity you're paying for without needing it. And once scale gets real, hundreds of containers, multiple servers, Docker alone won't be enough either. That's where Kubernetes comes in, but that's a subject for another video on this channel. The one where a single container stops being the unit you manage, and a whole fleet of them becomes the actual job.